Let's answer this acid-base calculation question from an old exam question paper. Download the question from the link below and try to answer the question yourself first. And don't forget to like and to subscribe and to check out my website, www.learnscience.coza. This question is about an acidic lake having pH 5. Now, it's not environmentally friendly to have acidic water. So somebody comes along and adds a few bags of a base, lime, calcium oxide, to the lake water in an attempt to neutralize the water. But clearly they don't succeed completely. How do we know that? Because sometime after this, we somehow determine that there's still this quantity of hydronium ions in the lake. In other words, it's still acidic. We're told the volume of the lake and we're given the neutralization reaction. And then we're asked to work out what mass of calcium oxide must have been put in the lake. How are we going to find that out from the information that we're given? In this kind of question, the first thing to realize is that one of the reactants is limiting and the other is in excess. That means that one gets used up completely, that's the limiting reagent, and then the other, there's still some left over after the reaction. That's the one in excess. Now, which is which in this particular example? We're told that there's still some hydronium ions left at the end. So hydronium is in excess. So we have calcium oxide, and that reacts completely with hydronium ions, and the hydronium is in excess, meaning there's still some left afterwards. Now, what is of importance for the chemical that's in excess? We need to know three things. We need to know the initial amount, the final amount, and the change in amount. Now, why do we need to know those? Well, actually, we only really need to know the change in amount. That's the same thing as saying how much of it reacted. But we use the initial and the final to find out the change. Now, why do we need to know how much hydronium reacted? Because that will tell us about how much calcium oxide must have reacted. And that is what we're really being asked. It might not look like that's what we're being asked, because we're being asked how much calcium oxide was put in. But all the calcium oxide that was put in reacted, because it's the limiting reagent. So if we can find out how much reacted, then we know how much was put in. So let's put in the information we know already. We know the concentration of hydronium ions initially. And then we're told right at the end the final number of moles of hydronium ions. Now, can you see that we need to be a little bit careful here? Because, yes, change is initial minus final, but only if we're speaking about the same things. And we're not. This is concentration, this is number of moles. We can't go and subtract them. So we need to convert this into its equivalent amount of moles. How do we do that? Well, we know that concentration equals number of moles divided by volume. Number of moles equals concentration times volume, and we know the volume of the lake. So if we multiply this by the volume of the lake, we'll know how many moles of hydronium were in that lake at the start, and then we can do our subtraction to get the change, how much reacted. Let's not do that now, because we must still first get the big picture, the strategy. After we've got the strategy clear in our mind, then we can actually start executing the calculations. Okay, so the first part of our strategy is we are going to find out the change in amount of hydronium. In other words, how much hydronium actually reacted. Why do we want to get that? What is that going to help us? We are then going to use the stoichiometric ratio in which these two react to deduce, therefore, how much calcium oxide must have reacted. That will be in moles, because this one is going to give us moles of hydronium that reacted, and then we're going to make use of the balanced equation to then get the number of moles of calcium oxide, which therefore must have reacted. But be careful, what were we actually asked? We were asked the mass of calcium oxide that was put in the lake. Remember, we've already discussed that that is the same as the amount that actually reacted because it's limiting. So then we're going to convert that into mass of calcium oxide. So now let's do each of these 3 steps. First step, we get the change in hydronium ions. The initial hydronium ion number of moles minus the final number of moles of hydronium. And we could have just calculated this right here and transfer that. But let's write everything out in full so that we've got it all together. This is the concentration in mole per decimeter cubed. We multiply that by the volume of the lake. That gives us the number of moles. Notice how decimeter cubes cancel. That gives us the number of moles. Initially, we subtract away the number of moles that we have at the end. So, let's do our calculation with our calculator. 1 times 10 to the power minus 5 multiplied by 4 times 10 to the power 9 is equal to 40,000 minus 1.26 times 10 to the power 3 equals 38,740. Let us store that into memory. So we say shift recall, which then makes it store A. Let's also not clear our calculator, so maybe we're not even going to need the memory. Okay, what is this that we calculated? How many moles of hydronium actually reacted? Second step, from this, we need to then work out how many moles of calcium oxide reacted. If 3,87 times 10 to the power 4 moles of hydronium reacted, how do we do that? We apply the balanced equations ratio. We know that 2 moles of hydronium react for every 1 mole of calcium oxide. So obviously we just have to divide this by 2 to find out how many moles of calcium oxide reacted. We still have this value on our calculator. So if you have cleared it, then recall A. But I still have it on the calculator, divide by 2. And so we have 1,937 times 10 to the power 4 moles of calcium oxide. So the next question is, we want to know how many grams calcium oxide is 1,937 times 10 to the power 4 moles of calcium oxide. We go to the periodic table to find out the molar mass of calcium oxide. Calcium, 40 grams per mole, oxygen, 16 grams per mole. 56 grams is the mass of 1 mole of calcium oxide. And so let's do that. We still have that on the calculator. Multiplied by 56 is equal to 1,08 times 10 to the power 6 grams